Okay, collecting and presenting data. Okay, question 1. This horizontal bar graph or horizontal column graph, pretty easy to read. Okay, really the only one that needs explanation is that one there. Why is it unsuitable to be in a sector graph? Because it's not comparing %, or the whole. Okay. Question 2. Alright. Why is this graph misleading? Okay, the big thing is it doesn't start on 0. It needs to be truncated just there. Other than that, the columns are equal size. What should it properly look like? Well, if you draw it obviously with the scale properly, it's probably going to more look like sort of like that, a lot closer. Alright, name another type of graph that could be used to display this data. Well, definitely a sector graph or a divided bar graph. Okay, 3. Categorical or quantitative or numerical, either way. The number of people, quantitative. Different brands, categories. Level of university degree, category. Temperatures, quantity. Number, quantity. Country of birth is categorical. Now, over the page, question 4 and 5 talk about, okay, of the numerical and of the quantitative. So is the numerical discrete or continuous? And of the categorical, is it ordinal or nominal? Now, let's look at the quantitative, the numerical ones first. Okay, so A is numerical or quantitative. Now the number of people, that is definitely discrete because it's found by counting. Okay, temperatures, D, is continuous because it's found by measuring. The number of levels in an office building, that is done by counting, so it is discrete. Now, of the categorical, different brands of surfing magazine, that is definitely nominal. There's no order to that. Levels of university degree, definitely ordered. For example, diploma, bachelor, PhD, whatever. There's an order to it. And F, country of birth, there's no order to that. Okay, we talked about 4 and 5. Question 6, describe what might happen at each stage of statistical investigation. Okay, so number 1, pose questions. 2, collect the data, maybe from a survey. 3, you organise it. 4, you display. 5, you analyse. And 6, you report. Okay, 7, at what stage does the researcher calculate statistics or use graphs? Now, I would say that's actually different. You use graphs at 4, which is display, but you calculate at analyze, which is part 5. Alright, so Burp Cola wants to check that each drink bottle is 1.25. Which type of sample is best? Definitely systematic, a system. It might be like every 10th or 20th or something like that. Okay, 9. To investigate the type of music to play at a school disco, Tasha surveyed a sample of 50 students visiting the canteen. Why might this be biased? It could be biased because you don't get a mixture of years maybe, or the more people at the canteen, might have different opinions. It's not really spread out. Okay, if she used the following year group and she wanted to do 50 students, in year 10, there's 128. Now when we add it all up, there is 677. So what fraction of 50? There's approximately 9 students will be from year 9. Okay, 10. What's wrong with each of the following survey questions? How often do you visit the doctor? Probably more like give them categories. How often did you visit the doctor last year? 0, 1 to 5, 6 to 10, greater than whatever, 20. What did you like or dislike about the film? It could be something like, firstly, how would you rate the film? Don't give them 2 questions in one, for one thing. Okay, how many people in the sample of this question here? Add it all up, you get 93. Now, graph this data in a sector graph. I'm going to do C first. What is the angle sector represented for not travel outside Australia? So that is 3 people have not travelled outside Australia because there's 0 countries apart from Australia. So 3 out of 93. We wanted it in the sector graph, which is out of 360 degrees, and we approximately get 12 degrees. So you just keep on doing that for all that, and you get hopefully 360 degrees, and you put it into sector graph. Alright, what percentage and visited 4 to 10? So there's 28 out of 93 times 100, because you want it this time in a percent. More than half of the sample had visited 11 countries or more. Okay, 11 countries or more, if you add up those, you get 50, that's more than half, so it's true. Okay, why would it be inappropriate to graph this data on a line graph? Well, a line graph is for numerical data, not intervals like this is. And the best numerical data for a line graph is continuous data. Okay, going from question 12 with all those masses, it's definitely continuous because there's a measurement. Now, when you organise it into frequency distribution table, you'll have your class and your frequency. Maybe your tally, but so 50 to that. When you count it over the other page, there are 4. 60 to 70, there are 12, ... keep on going, and in all there are 40 people surveyed. Okay, so if we wanted to draw a graph, a histogram and polygon, so obviously our classes, now it's probably better to go to 50 to 60 to 70, etc. And I think our highest number basically was 12, which we can maybe go up by 2s, so it gets to 12. So 50 to 60 was 4, then we go to 12, and so on. Now, with the polygon, we start somewhere here, mainly halfway in the gap, and then we go to the middle, and then down somewhere there to the next column. Now, which interval has the highest frequency? So that is 60 to 70. What fraction of skydivers were 80 to 90? So I think there were 8 out of 40, which becomes 1/5, which can be done on a calculator. Alright, so 13, dot plot. So our lowest number is 0, and we go up to, obviously using a ruler. Okay, there is 1 0, there is 2 1s, there is 2 2s, etc. There are 5 6s, there are no 7s, so we don't put anything there, and there's 1 8, so there's obviously some in there too, but we'll just leave that. How many children were in the sample? Count all the numbers, and there's 24. What fraction with over 5? Don't include 5. That's 6 out of 24, which gives you a quarter. Comment on any clusters. Now there's clusters, when you look at clusters between 3 and 6, that's where most of the peaks are. Now an outlier, because there's all numbers in here, you might be able to class that as an outlier, but it's only really 2 away, so you could probably say 8 was an outlier, but really it isn't. Okay, 14. What was the age of the youngest visitor? 3 years old. Oldest is 58. How many visited the show? Well, when you count all those numbers, you get 29. The most common, okay, we see that 2 occurs 3 times in that one. So the most common would be 12 years of age. And what percentage of visitors were over 30? So we're talking about those ones there. Count the number. There are 12 out of the 29. Times that by 100. Okay. 15. Okay. Radar chart's pretty easy. Okay, which month show the second highest earnings? Okay, September looks like it's the highest. November's a bit higher than October, so November. Estimate the earnings in Feb. Okay, Feb, which is around about there. It's between 3,000 and 4,000, probably a little bit lower than half. So I'm going to go that. Which month did the contractor earn 6,800? 6,800. Okay, so there's around about 7,000. I'd say May, just a bit. We had to decrease the most from June to July, just in that dip there. How many months did the contractor earn more than 8,000? Well, we've got September, October, November, and June. So that's 4.